What is the remainder theorem? The remainder theorem states that if you divide a polynomial f of x by a factor of x minus k, the remainder will be equal to f of k. Why should we use it? Well, the remainder theorem can serve as a simpler and more efficient way to evaluate a polynomial.
How would we use it? We use the remainder theorem to evaluate a polynomial f of x by utilizing synthetic or long division to divide the polynomial f of x, which is the dividend, by the polynomial d of x, which is the divisor, to find the remainder. What is the factor theorem? The factor theorem states that a polynomial f of x has a factor x minus k, if and only if f of k equals 0. Why do we use the factor theorem? The factor theorem is used to show whether x minus k is a factor of a polynomial f of x. How do we apply it? You apply the factor theorem by evaluating the polynomial at x equals k. If the result is 0, x minus k is a factor of the given polynomial.
Here's a simple example of applying the remainder theorem to evaluate the polynomial function.
Use the remainder theorem to evaluate the following function. F of x equals to 5x cubed plus 6x plus 8 when x equals to 2.
As you can see here, by using synthetic division, we can come up with a remainder of 60. By the remainder theorem, we can conclude that f of 2 is equal to 60.
You can see here that the same result is achieved when substituting 2 into the given function and when applying the remainder theorem. One of the most common errors made is failing to recognize that in the remainder theorem, the polynomial is divided by x minus k. Therefore, x plus 5 should be changed to x minus negative 5, and as a result, the k value is negative 5 as opposed to positive 5. As you can see here in the polynomial 3x to the 4th power plus 2x squared plus 3x plus 5, we must substitute 0x cubed as a placeholder. Failure to do so will result in a completely different answer. Here we see a more difficult and complex question, where we are given the polynomials f of x and a factor of x minus radical 2 minus 2. Notice we substitute 0 as a placeholder between the 4th power and the 2nd power, and how the k value used in synthetic division must be found by isolating the k value in x minus k. Find all real solutions of the polynomial equation. Here we see an example where both the remainder theorem and factor theorem are utilized. As you can see here, the first step is to use the rational zero test to find all possible rational zeros. The next step is to use the remainder theorem and test each of the possible zeros by dividing the polynomial by each of the values with synthetic division. We know, because of the factor theorem, that a result of 0 means the value is a solution to the polynomial. We then end up with x squared plus 2 equals 0. Because radical negative 2 is an imaginary number, the only solutions for this problem are negative 1 and 2.